Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on discrete Fourier transform, that is linear convolution. The convolution sum relates the input, output and unit sample response of discrete time systems. Linear convolution is a very powerful technique used for the analysis of linear time invariant systems. X of n can be expressed as sum of weighted impulses. Y of n is equal to x of n into h of n. The behavior of the LTA system is completely characteristic by the unit sample response h of n. Therefore, y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. It is the linear convolution of x of n and h of n gives output y of n. X of n can be applied to your linear time invariant discrete time system, which can produce the output as y of n. This is the representation of convolution. The input sequence can also be given. The input sequence, second input sequence can be also be given. While we taking the convolution of both these x of n and x1 of n, we can get the output sequence as a convoluted sequence is nothing but your third representation. This is the representation of convolution of your previous graphical representation. X1 of n can be represents 1, 2, 3, 4, 5, 6. X of n also represents 1, 2, 3, 4, 5, 6. We can multiply 1 into 1, then 1 into 2, 1 into 3, 1 into 4, 1 into 5, 1 into 6. Similarly, for 2 can multiply it with all the 6, 3 can multiply all the 6. Now we can 4, 5, 6. Finally, by using tabulation method, we can get the output as y of n is equal to 1, 2 plus 2, 4, 3 plus 4 plus 3, 10, 4 plus 6 plus 6 plus 4, which is equal to 20, and then 5 plus 8 plus 9 plus 8 plus 5, which is equal to 35, and then 6 plus 10 plus 12 plus 12 plus 10 plus 6, which is equal to 56. And then 12, 15, 16, 15, 12, we can get it as your 70. 18, 20, 20, 18, we can get it as your 76. And then 24, 25, 30, 24, we can get it as 73. 30 plus 30, 60. We can finally we can get it as a 36. Therefore, y of n is equal to 1, 4, 10, 20, 35, 56, 70, 76, 73, 60, 36. Next one, 4 methods involved in computing convolution sum, that is nothing but definition method, graphical method, tabulation method and multiplication method. What are all the 4 steps involved in computing linear convolution? Folding, second one is shifting, multiplication and summation. Let m be the total number of samples of x of n and capital N be the total number of samples of h of n. Then the total number of samples in y of n will be m plus n minus 1. Next one, this is the convolution sum of the input sequences and the impulse sequences. We can going to compute by using linear convolution and circular convolution. By using for the above two sequences, the convoluted sequence can be given as 0 is equal to 1, 1 is equal to 2, 2 is equal to 3, 4, 3 is equal to 6, 4 is equal to 6, 5 is equal to 7, 6 is equal to 6, then 7 is equal to 4, 8 is equal to 2. This is the convoluted sequence of input sequences into impulse sequences. Now we can get the convolution sum of the previous one. X of n is equal to 1, 1, 1, 2, 1, 1, h of n is equal to 1, 1, 2, 1. By using matrix multiplication method, 1, 1, 1, 2, 1, 1, 1, 1, 2, 1, we can multiply with all the ones and 2 and then 1, again 1. Now we can going to add all these sequences. We can get the output as y of n is equal to 1, 2, 4, 6, 6, 7, 5, 3, 1. This is the output sequence of the given input sequences x of n and h of n. Next one, properties of convolution sum. It can be classified into 3 properties: commutative property, associative property and distributive property. Commutative can be given as y of n is equal to x of n into h of n, which is equal to h of n into x of n. The graphical representation can also be given. and then associative x of n multiplied with h1 of n again multiplied with h2 of n, which is equal to x of n into h1 of n into h2 of n. The graphical representation both for left hand side sequence and right hand side sequence can also be given. Next one, distributive property. X of n multiplied with h1 of n added with x of n multiplied with h2 of n, which is equal to x of n into h1 of n plus h2 of n. For left hand side sequence, the graphical representation, and the right hand side graphical representation of distributive properties as shown. And then this is the input and output transference when x of n can be applied to impulse response, which can produce the output as y of n. When x of n will be applying the linear change x dash of n, that can be applied with the impulse response, which can produce the output as y dash of n. Next one, graphical representation. X of k, h of k can be already given. How to find your h of minus k? This is the folded signal of h of k is nothing but h of minus k. H of 1 minus k means one time shifted with right hand side, that is nothing but h of 1 minus k. Similarly, for 2 minus k, h of minus k can be shifted by two sequences, two steps. H of minus 1 means h of minus k can be already given. H of minus 1 means that is the folded signal can be shifted by one sequences. Finally, we can get the output as y of n. Next one, multiplication method. Find the convolution sum of the sequence x of n is equal to 1, 2, 3, 4, 5. H of n is equal to 6, 7, 8. Now we can multiply with x of n with 8 all the samples, and then 7 and then 6. Now we can add all the samples. We can get it as here y of n is equal to 6, 19, 40, 61, 82, 67, 40. Same sum followed by tabulation method 1, 2, 3, 4, 5, 6, 7, 8. Now we can multiply it with 1 with 6, 7, 8, and then 2, 3, 4, 5. Now we can add it with y of n is equal to 6, 12 plus 7, 19, 18 plus 14 plus 8, 40, 24, 21, 16, we can get 61, 30, 28, 24, 82, 35, 32, 67, finally we can get it as 40 y of n, which is equal to next definition method can be also be given x of n is equal to 1, 2, 3, 4, 5, h of n is equal to 6, 7, 8. Now total number of samples of x of n will be m, and total number of samples of h of n will be n. M plus n minus 1, 5 plus 3 minus 1, 8 minus 1, which is equal to 7. N varies from 0 to 8. Now we can limit this here. Lower limit is your 0, upper limit is your 4. X of k into h of n minus k. N varies from 0 to 6. Now we can substitute is your limits x of k into h of 0 minus k, which is equal to minus k. N varies from 0 to 6. N is equal to 0, 1, 2, 3, 4, 5, 6. And then substituting the values instead of x of k and h of whatever may be. Now we can get the result as y of n is equal to 6, 19, 40, 61, 82, 67, 40. Can also verified by using tabulation method or multiplication method. Next one, assessment. Define linear convolution. Linear convolution can be defined as y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Total number of samples in y of n will be m plus n minus 1. List the methods involved to compute linear convolution. There are 4 methods involved to compute linear convolution. First one is definition method, graphical method, multiplication method, and tabulation method. Y of n is equal to x of n into h of n, and h of n into h of n is defined as commutative property. Mention the steps involved to compute linear convolution: folding, shifting, multiplication, and then summation. List the properties of convolution sum: commutative property, associative property, and distributive property. Thank you.